In this section, we're going to look at the iOS EasyVPN client configuration in three separate modes: the client mode, the network extension mode, and the network plus mode. Now, we already saw the EasyVPN server configuration that we did on router 3, and we used the test PC running the actual Cisco VPN client on Windows to connect to it. Now we're going to look at this by using the same server configuration on router 3, but we're going to use the iOS as the client. And specifically, we're going to be using router 5 in this case. Now, the three different modes we'll look at, the client mode, network extension, and network plus mode, are essentially going to control, is an IP address assigned from the EasyVPN server down to the client, and is the client going to be running network address translation and port address translation. Now, we saw with the previous tunnels some problems in the basic transport of the tunnel based on filtering that was going on in the network, specifically on the ASA. So before we get into any problems that are related to that filtering, we're just going to fix those issues straight off the bat. And this is the type of methodology that you would want to apply in a real design, or in the case of the CCIE lab exam, you want to make sure to fix these problems before they occur. So simply based on the way that the diagram is outlined here, we can tell that if we want to connect the client from 5 to router 3, that the packets are going to have to go to the ASA, from the ASA to router 2, then from router 2 to 3, and then finally in the reverse direction. So if we have any type of filtering, whether it be the ASA, the content-based access control, the zone-based policy firewall, or just maybe some static access lists, we want to take that into account and try to fix those issues before we see them manifest in the actual client configuration. In this particular case, the way I'm going to solve the problem is on the ASA. As traffic is coming in on the inside interface and going to the outside, we're going to tell it to simply inspect the IPsec payload. So the ASA is now going to know when the ESP traffic moves from the inside to the outside, then it tries to return. We're going to automatically allow this back in. Now, I don't need to change anything that is related to the Phase 1 ISACamp negotiation, because UDP port 500 is automatically going to be inspected by default. So next, let's go to the command line on the ASA. And if we look at the show run policy map, we can see that with the default global policy, we are not inspecting the IPsec traffic. So now let's go under this global policy, and we'll specify that in addition to the other default inspection traffics, we want to inspect IPsec pass-through. Now, if we wanted to change the details of this inspection, we then could call an optional IPsec pass-through type policy map we can see, which is going to control the individual options of ESP, of AH, and the timers that are related to them. But here, just by inspecting IPsec pass-through, that's going to be the basic defaults that we need. So next, we need to go to router 5 and configure it as the client. The iOS EasyVPN client is going to specify where is the traffic coming from on the inside, and then where is the traffic going to on the outside. So similar to the CBAC or the zone-based policy firewall, the VPN client is going to use the inside and outside naming conventions in order to control when is the tunnel going to be initiated. So will the tunnel automatically start when traffic moves from the inside to the outside? Or are we going to have to manually initiate it with the crypto IPsec EasyVPN client connect command? So now let's take a look at the documentation. If we go to the main 12.4T configuration guides page, just like our other IPsec topics, this is going to be located down under security and VPN, then under secure connectivity. Then we have EasyVPN and the EasyVPN remote feature. Just like the server, we could configure this two ways based on the documentation examples. We could go through the configuration task list. So how to configure the remote and look at all the different possible options. We see there's multiple minor features that we can change here, like running TCP tunneling, which by default we're not going to do any type of transparent tunneling. We're going to be running the tunnel directly over ESP. We could have the manual tunnel establishment. We could have automatic tunnel establishment. So do take some time to read through the document and see what the features are. But overall, you could, just like the server configuration, essentially take their example here towards the end, and we could pretty much just copy and paste this to change what particular options around that we need. Where I'm going to look at there's a couple different examples. The EasyVPN client in network extension mode on the 1700, where most of this is related just to the rest of the routing configuration. We can see it's running DHCP server. Really, the only thing that we need is just the crypto IPsec client config, and then at the interface level, the actual application of the client. So if we look at this in Notepad, we have the crypto IPsec client, EasyVPN. This is just the name of the configuration here. So we'll say EasyVPN config, where the group name, this is what we have configured on the server, where I had EasyVPN underscore group. Then the key is going to be the pre-shared key for the phase 1 ISACamp negotiation. The pure address is going to be router 3, so 200.0.23.3. And for our first example, we're going to start in the client mode. Then at the interface, router 5 has two interfaces. It has Fast Ethernet 0/1, which is going to be the outside, and Fast Ethernet 0/0, which is going to be the inside. So on Fast Ethernet 0/1, which is the outside interface, we have the crypto IPsec client, EasyVPN, then its name, which in this case I called EasyVPN underscore config. I need to specify that this is the outside interface. Then on Fast Ethernet 0/0, this is the inside interface. So we can see overall, compared to the server, the EasyVPN server configuration, there's really not that much that we need to add in order to get the client functionality. Most of the possible mistakes or most of the troubleshooting is probably going to be related to the server configuration versus the client. So next on router 5, we're going to apply this client configuration, and we're going to look at two debugs. The debug crypto IPsec client, EasyVPN. Then on router 3, who is the server, we'll look at the debug crypto ISACamp and the debug crypto IPsec. So our normal two standard debugs for any VPN tunnel, whether it's LAN to LAN or whether it's remote access. So now let's apply the first portion, which is the client configuration group. If we look at some of the other options here, the other one we may want to change is how does the connection happen? Does it happen automatically, or are we going to manually initiate it? Also, we can reference an access list that would be for interesting traffic, where we could say potentially, I want to start the tunnel if someone tries to run port 80 to this particular destination, or they send a ping to this address that's on the other end of the tunnel. Then lastly, we're going to apply the configuration onto the interfaces. Now, to actually initiate the tunnel, we need to say from exec mode, crypto IPsec client, EasyVPN connect. Then when we need to do our extended authentication for the phase 1.5, we would say crypto IPsec client, EasyVPN XAuth, and then actually enter the username and password that the server has configured. So with this first command, this should initiate the basic phase 1 negotiation, where it says now we have a pending extended authentication request that we need to use this command, crypto IPsec client EasyVPN XAuth, in order to actually enter the username and password. But what this should now tell us is that phase 1 negotiation is complete. If we look at the show crypto ISACamp SA, we're now in the extended authentication mode, but it means that our basic phase 1 proposal and the group authentication was correct. Likewise, if we were to look at this on router 3, it's going to be the same output as any remote access tunnel negotiation, where first off it says that we have a client that's coming in, which has the address 10.0.125.5. It's using port 500, which is for our ISACamp negotiation. The username they sent was the EasyVPN_group. We should then see the pre-shared authentication occur and the phase 1 policy be negotiated. Eventually, we want to see somewhere it says that the attributes are acceptable. Just like the normal client configuration, this is going to be based on the combination of the ISACamp policy that is on the server and the particular options that that version of the client can offer. So eventually, down towards the bottom, we should see that they agree on some set of phase 1, which in this case it says the attributes are acceptable. We're going to run triple des, MD5, Diffie-Hellman group 2, and using extended authentication with the pre-shared keys for the group authentication. So once phase 1 is negotiated, we should see now that phase 1 is complete, and we start to go into the extended authentication. We're going to assign them an address from the pool, 172.16.255.16. This is happening through mode configuration. Now phase 1 is complete, and we're going to actually do the authentication and then the establishment of the SAs. So if we run this again, we'll say crypto IPsec client EasyVPN connect. We should see it returns that the output we need to now do XAuth, where router 3 has the username and password Cisco configured. Now we see the actual negotiation of the rest of the tunnel. Router 3 was assigned the client address 172.16.255.17, and it says that this was assigned to the loopback 10,000 interface. And if we look at the show IP interface brief, we can see that address has been assigned to the loopback interface of router 3 or router 5. Now, since we are running in the client mode, this should behave essentially the same as the end host's EasyVPN client, which means that when traffic goes from the inside to the outside, it's going to be encapsulated inside of the tunnel, and the source address is going to be changing to whatever the IP address that the server allocated. So if we were to go to router 6 and then send a packet over the tunnel to router 4, router 4 should now see this coming from the address of the tunnel negotiation, which was 172.16.255.17 in this case. If we now go to router 6, and let's telnet to router 4, to one of the addresses behind the VPN. We can see right now router 6 doesn't have reachability to 4. So now let's verify that the rest of the tunnel is actually working. If we go to router 5, who is the client, and look at the show crypto ISACamp SA, we should see that phase 1 is complete and it's in quick mode idle. If we look at the show crypto IPsec SA, we do have the tunnel that's going out to the remote peer, which is router 3. It says that packets are getting encapsulated, but packets are not getting decapsulated. If we look at router 3 and do the same thing, let's look at the show crypto ISACamp SA. We should see phase 1 is complete. We're in quick mode idle. If we look at the show crypto IPsec SA, and we are looking for this tunnel that's going to 172.16.255.17, it says that packets have been decapsulated and they are getting encapsulated, but for some reason they're not returning back to the other end. So like we saw before in some of our previous tunnel examples, most likely this is now a filtering problem in the data plane, where the traffic is getting from 6 to 5, 5 put it into the tunnel to 3, 3 got it decapsulated, sent it to the destination, destination is replying, 3 sends it back out the tunnel, but then somewhere before router 5 it's getting dropped. So now let's look at the ASA and make sure the IPsec inspection is actually working. If we look at the show connections, right now we do not see an IPsec inspection, or more specifically an ESP inspection. There are also some log messages here. It says that traffic was denied. That was protocol 50. That was coming from router 3 on the outside, going to router 5 on the inside. So it looks like the ESP inspection didn't actually occur here. On the ASA now, let's look at the show run policy map. And we do have the inspection configured. What I may need to do now is to remove the policy and then reapply it to make sure this inspection is actually occurring. So let's say show run service policy, where we have the global policy applied globally. We'll remove this, reapply it, and then let's clear all of our connections. Let's say clear connections all. Now on the VPN client, who's router 5, let's disconnect the client configuration and then we'll reconnect it. So we'll say clear crypto IPsec client EasyVPN. Then we'll reconnect this. Crypto IPsec client EasyVPN connect. If this is successful, we should get the message back now that we need to do the extended authentication, which we have. We can see our address was assigned. Now we are the 255.18 address. And if we look at the ASA, let's say show connections, now we see the UDP traffic for the phase 1 tunnel, and then also the ESP traffic for the phase 2 tunnel, or the IPsec SA. So now let's try this again. Let's go to router 6, telnet to 4. We can see now it's working. On router 4, if we look at the show users, we can see the address that the telnet session was sourced from was the network address translation, or the post network address translation address of the tunnel from 5 to 3. So this now tells us that the client running in client mode is actually encapsulating the traffic, and it is doing the network address translation. If we were to go to router 3 and again look at the show crypto IPsec SA, we should now see for that address .18 that we have a security association. Packets are getting encapsulated and packets are getting decapsulated. On router 4, if we look at the debug IP ICMP, then send some pings from router 6. Let's ping 172.16.4.4, and we'll keep this going. We'll do a high repeat count. We should now see that these packets are coming from the address of the tunnel, the .255.18 address. If I were to then disconnect the tunnel on router 5, we'll say clear crypto IPsec client EasyVPN. We should see now that the address is going to change to the actual inside address of router 6. So 2 good basic verifications you can do Just by looking at the debug IP ICMP, we can tell where the traffic was originated from. And also when we telnet into the console or telnet into the exec process and look at the show users, it's going to tell us what the source address of that particular telnet session is. Now notice here that the packets are getting dropped when we are not sending them over the tunnel. This is because the global policy on the ASA, and if we look at that show run policy map output, we can see this is not inspecting the ICMP traffic. So the ASA is now only allowing the traffic from the outside in if it is ESP or if it is the other normal default inspection protocols, the UDP, the TCP, and then these application level ones. So if we take a look at the configuration on router 5, you can see there's not that many options that you need to do in order to get just the most basic client configuration working. We have the group name and the group password. Then we have the peer address, which is router 3. And the defaults are that we're going to run in client mode and that extended authentication is going to happen interactively, which basically means we need to manually enter the username and password. And then if we were to change this to say connect auto, it's automatically going to initiate the tunnel anytime traffic leaves the outside interface. So then we have our two interfaces. This one is the inside, this one is the outside. Now, if we were to change this to run in the network extension mode, so now on router 5, let's say clear crypto, IPsec client, EasyVPN. Then we're going to change this to run in network extension mode as opposed to client mode or as opposed to network plus mode. Now, again, the main difference between these three, the first one, which is the client mode, means that we are going to allocate an address from the EasyVPN server, where previously we saw that it was the 172.16.255 addresses. With network extension mode, it's more like a LAN-to-LAN IPsec tunnel, where we're not doing any translation, but the difference is that the tunnel is dynamically negotiated instead of a normal static LAN-to-LAN tunnel. Then lastly, the Network Plus mode is a combination of the client and the network extension that we do get an address assigned, but we don't actually do the network address translation to it. So it's more just for testing to see, can we actually get an address allocated down to us? So other than this, just one command, changing from mode client to mode network extension, everything else should be the same. So now if we say crypto IPsec client EasyVPN connect, if phase 1 negotiation was correct, we should get the log message saying we now need to do extended authentication, which we do. If we look at router 6, we can see now that the tunnel is up. The packets are getting through because now the ASA is allowing the ESP. But if we look at router 4, notice that the destination the packets are going back to is the original inside address of router 6. So it is now not being network address translated, similar to what it was before, where it was getting this 172.16.255 address. So the idea behind this is now from router 4's perspective, we don't have any issues with trying to get to an application that is behind the EasyVPN client. So for example, this 10.0.6.0 network, if there was a web server here, we would not have any problem with initiating a connection from the outside to the inside because we're not doing a port address translation. In the EasyVPN client mode, since the web server's address would be port address translated to whatever the address of the tunnel is, we would not be able to initiate traffic from the outside in. Now, if we were to run the third mode, which is the Network Plus, so if we go to the crypto IPsec client, and we'll change the mode to Network network plus, when we reconnect the tunnel, and right now we should see router 6 is dropping packets, which it is. If we reconnect the tunnel, we should get the log message for extended authentication. We should see now router 6 should be able to send packets, which it can. And on router 4, when we look at the debug, notice that it's the same address on router 6. So right now we're not doing a network address translation. However, if we look at the EasyVPN client, who again is router 5, it says that an address was assigned to us, 172.16.255.19, and it's assigned to our loopback 10,000. We can see this if we look at show IP interface brief. So this is now telling us two things. Not only is the client's configuration correct, but the server's configuration is correct, where it is able to actually allocate an address from its DHCP pool or from its local pool. Now on router 4, actually let's stop this ping on 6. If I were to telnet from 6 to 4, when we log in here and look at the show users, the source address is going to be what? Source address is going to be the tunnel address, or it's going to be the original address of 6. In network extension mode, it's going to be the original address, so we're not performing network address translation. However, if I were to send packets back to the tunnel address, which is now the 255.19, notice that router 4 is able to send packets to that address, and they land on router 5. But likewise from router 5, if we were to telnet back to router 4 and look at the show users, notice the address here, it is not getting network address translated. So we're still able to reference the address that was assigned to the tunnel, but when traffic goes out the tunnel, it's not actually going to be network address translated or port address translated to that particular address. But again, in either case, when we look at the final configuration, very, very straightforward for the client. Just like the server, you should be able to piece this together from the documentation. And if you know the normal verification and the normal troubleshooting steps for IPsec, nothing else is changing here. So we still need to agree on the phase 1 ISACAMP SA, where in the ISACAMP SA, we're negotiating the authentication, which in the case of the EasyVPN server and client, this is going to be the group username and the group password. We have our encryption, we have our hash algorithm, we have our Diffie-Hellman group. Then we go to our mode config and our extended authentication, which is our phase 1.5. Then we go on to, so this is phase 1, this is 1.5. Then we go on to phase 2, which is the who, the what, and the how. Where who is going to be the peer address. So on the client, we're specifying the server's address, but the server doesn't know the client's or the initiator's address until the tunnel actually starts. Then the what, this is going to be controlled by the access list that is defined on the server. Or in other words, this is the split tunnel ACL. So the split tunnel ACL for EasyVPN is like the proxy ACL or the proxy identities that we saw with the LAN-to-LAN tunnels. Then the how is still going to be controlled by the transform set. So the key is that if you understand the overall logic of how the tunnel is pieced together, it's not going to make a difference of whether we're running LAN-to-LAN or remote access, or whether we're running it on the iOS or the ASA, because it's the same individual pieces that are used to build the phase 1 tunnel, the phase 1.5, and the phase 2 tunnel.